Hi there. Welcome to section 3.2, the periodic table. The periodic table was put together, there was a gentleman named Dmitry Mendeleev who had some students, and he was trying to find a way that they could associate things or atoms that had similar properties. And so he arranged the elements according to those properties, and he came up with a solution for this. And so what he did was he had groups and periods, and groups are the elements in the vertical columns, and periods are in the horizontal rows. Okay, so a group would be a column going down, a row would be those elements going across in a horizontal row. And so anything that's in the same column here is going to have similar properties. Anything that is in a similar row will also have similar properties or some type of relation. And so what we're going to do is we're going to look at these. And so the example that I'm going to show you here first is, this is group 2A, and the way these are is it's 1A, 2A, 3A, 4, 5, 6, 7A, and 8A. Okay, so they're named like that in these groups, and all these groups are going to have a name, and they're going to have similar properties. A period, okay, you name them as you go down, 1, 2, 3, 4, 5, etc. All right, as you go down. And so the things that are in group 2A are going to have similar atomic properties and often similar reactions they'll undergo, and also similar physical chemical properties in general that you'll see as you move down a group. Okay, so here is the periodic table of the elements, and in chemistry we call this the ultimate cheat sheet, because if once you can use the information in one of these, you can pretty much tell a lot about each of these individual elements just by knowing its number here, its atomic number. If you have the atomic mass, sometimes that will be related right here. The symbol, okay, that we're going to look at, we looked at some of these: carbon, phosphorus, chlorine, okay, and then they also have names of these different groups. For example, 1A is alkali metals, alkaline earth metals. These are halogens in group 7A, noble gases, and then there are others. So we're going to look at those a little bit. We're also going to see metals. There's a line here that goes down, this zigzag line we call it, okay, and everything to the left of that is a metal. And everything to the right of this is a non-metal. And there are some that touch the line that actually have properties of both a metal and a non-metal. So, in the group numbering, you use the letter A for what we call the representative elements. Okay, those that follow the rules really well, and those are groups 1A through 8A. The letter B, okay, which is going to be this group in here, are called transition elements, and they go from 3B to 12B, and they have a little bit different way of reacting sometimes, and these include a lot of the metals that we know, like iron, manganese, chromium, titanium. These are the things like that we know, we've heard of as metals. So the group classifications, as we said, the common name for group 1A is alkali metals. Group 2A is alkaline earth metals. We have the transition elements that are, remember, 3B, okay, and they go all the way over to 13B. The 8A are called the noble gases, and then 7A are halogens. The rest of these don't really have common names, so these are the main ones that we're going to want to remember. The alkali metals, group 1A, the alkaline earth metals, group 2A, 7A, which is halogens, 8A, which are the noble gases, and then the B's that are kind of this down in a hole here, the transition elements. So, starting with the alkali metals, which are group 1A, the alkali metals include lithium, sodium, potassium, rubidium, and cesium. And they all have very similar properties. Notice that they are kind of soft-looking metals. Group 7A, called the halogens, include fluorine, chlorine, bromine, iodine. These are the ones that we're most familiar with, okay, and the ones that we will be dealing with in this course. So let's see if we can identify the elements by describing where they are, okay? So if you go to group 7A, that's the column, period 4, which one do you see? Group 2A, period 3, and group 5A, period 2. Go ahead and see which one you think it is, and then let's check it. So, if you went group 7A, that's our halogens, and period 4, that should have been bromine. Group 2A, period 3 should have been what? Magnesium. And group 5A, period 2 should be nitrogen. Very good. Now, I mentioned that you had metals over here, nonmetals over here in the yellow. We use this jagged line as the place where we separate those. Okay, but anything that's in green here that's touching this zigzag line we call metalloids. Okay, metalloids are located along this zigzag line between the metals and the nonmetals, and we do that because they have properties of both metals and nonmetals. So these are the metalloids: boron, silicon, arsenic, polonium, these guys, and then Ge, Sb, Te, At. These are the most common ones you're going to see are boron, silicon, and arsenic as far as what we see in this course. They're the more common. So, characteristics or properties of these different types of elements. Metals are shiny and ductile. What does ductile mean? Okay, it means they bend. They are good conductors of heat and electricity. Okay, so what do we think of? Maybe copper or iron, something like that as a metal. Nonmetals are dull, brittle, and poor conductors, but they are good insulators. And so these are like carbon, boron, which is kind of a metalloid, but it still has some of these properties. The metalloids, as we said, you're going to see they are better conductors than nonmetals, but they're not the greatest of conductors, but they are good. If you've heard of silicon, okay, silicon is used in semiconductors, and you also can use some of these metalloids in insulators. So this is just a table of some characteristics of the metal, a metalloid, and a nonmetal. Silver, antimony, and sulfur, just so you can look and see how they compare to each other. Notice that the higher melting point you're going to see in the metal midpoint, typically these metalloids, and so and then of course the lowest in the sulfur. And ductile, brittle. This can be shaped into different shapes. That's called malleability. These others are too brittle; they will shatter. And so there are pretty big differences between the groups metal and non-metal, and then the metalloids are like a kind of a middle range. So let's identify the following as either a metal, a non-metal, or a metalloid. Okay, so sodium. Sodium is, what's its symbol first? You got to know that first. The symbol is what? Na. That's sodium. And so here is sodium. Is sodium a metal, a non-metal, or a metalloid? It is in blue, so it is a metal. And we also know because it's what? To the left of that jagged line. Chlorine is to the right. Okay, so it is a non-metal. Silicon is touching the line. It's in green, so it's a metalloid. Iron is in blue, so it is a metal. And then carbon is up here, and carbon is a non-metal. Very good. So list all of the elements that match a description. Okay, so metals in group 4A. So we've got 1A, 2A, 3A, 4A. All the metals in this list that are in group 4A, I see silicon, okay, and germanium, and tin, and lead, and carbon, right? Non-metals in group, now, they're all in group 4A, but what is it asking for? What are the metals? Okay, what color would the metals be? Blue. So as far as the metals that are in there, it's going to be what? Tin and lead. Very good. All right, non-metals in group 5A. Here's 5A. How do we know it's a non-metal? It's to the right, okay, but it can't be a metalloid, yes. So I see two that are here that are non-metals, nitrogen and phosphorus. And then finally, metalloids in group 4A. Back to 4A. Metalloids would be what? Silicon and what? Germanium. Okay? So the same group can have different classifications. Metal, non-metal, and metalloids, can it? So that's the end of the periodic table section. I hope you enjoyed this. I hope you learned something anyway. And so we will be back with section 3.3 whenever you're ready.